Hello and welcome to Embedded Room, a place where we discuss about embedded technologies. When working with temperatures in any application, it's very important to have a good and robust input for your algorithm, which will be used in order to drive something. It's very important, so for this I think it's a good reason to address this topic, and it may fit your requirements as well. So let's say that we have a temperature which is in 0.1 resolution, and this temperature we will feed in with an initial value which is 0 to this block. And here in this temp hist block we will try to implement an algorithm in order to manipulate the temperature and to have a more stable output. It's not an damping but a configurable linear increase. So let's just run this to see what we have for now. So this is empty. So basically now we will have only the jump from 0 to 70 degrees. So we will try to implement something, and we will try to have something like this. Yes, some steps here to increase and control the output and so on. Let's jump to the block itself and start the implementation. So first what I'm gonna do here is that I will add a new parameter, which I will call it temp hist, and we will use this also in this implementation. Basically what we want to accomplish with this one is that if the temperature oscillates a little bit, you see that we have a 0.1 there resolution. We want to consider a valid temperature only if it exceeds, meaning it will increase or decrease a certain threshold. So for now we will declare a persistent variable. Let's see, persistent temp out previous. We will use this to store the previous temperature. Then we will also use another variable which will be used to take the difference between the actual temperature and the next cycle temperature, and this will be a UN16 will be 0. We also want to initialize the persistent variable, so we do like this: if is empty, we will take temp out prev and say we will initialize this one with temperature in. Good. Now we want to check, let's say, check if temperature is rising. If temp in is greater than the temp out previous, then we want to calculate, let's say calculate the difference between temperature input and temperature output, and we do this like this, temperature diff takes temperature in minus temp out prev. So basically we want the difference between temperature input and the output. If this is true, then we have an increasing temperature. We are not yet decided if this is really the case and take this as a real increase. Maybe it's just a fake one in our case, because we want to be more stable and reduce or ignore the noise. So for this we want to check again if temperature difference is greater or equal than the temperature hist. Then we will increase the output with 1. Increase output with 1 hist value, meaning if the hysteresis is 0.5 degrees, meaning if this 0.5 threshold was exceeded, we will consider as a change. Of course, the temperature can oscillate 0.1, 0.2, 0.3, go a little bit back and forth, so on, but we do not consider the temperature only if it exceeds this threshold. Good. So for this one, we will say temp out prev equals temp out prev plus, and we make a cast here, temperature hist. Good. So basically we are done with the increasing scenario. Then we want to do all the same for the decreasing. So we check again, check if the temperature is decreasing. We will use here an if and basically let's do like this and remove this and use an else if, and here an and. Else if the temperature input is less than the temp out prev, yes, then we want to calculate the difference between T out and T in. Why this? Because we want to avoid the negative numbers. Good. So temp diff is the temperature out prev minus the temperature in. Good. Now we want to do again the check if the temperature diff is greater than temperature hist. Of course we close the if here and we say decrease output 1 hysteresis value. Of course we use the same value for now for increasing and decreasing, but this can be extended and use different variables for rising and falling, for example, but we will just keep it simple for now. and temperature out prev equals temperature out prev minus, in this case, and the cast here with temperature hist. Good. Now we only have another scenario, which is about if this if and else is not true. It's not possible, so we only need to output to give this one a value. So this is used here, which is previous. Here we do the checking for the increasing, for the falling, and at the end we just let the temperature output to be temperature out prev. Okay, let's see if this works with a short example. We go back to the Simulink, and like I said, we have just one scenario, a simple scenario, to have a 70 degrees input with an initial value in order to have another, a step to increase from 0 to 70, and we will try to see the output. Of course, we need to add here the hysteresis values, and I say 5, meaning it should increase with 0.5 degrees. Okay, let's do this maybe in 16. Maybe it's too much, but why not? Okay, and run. Good. Okay, so as you can see, with yellow is the without algorithm, where we have from 0 a jump to 70 degrees, and this is the second one with algorithm, where we have a linear increase step by step. Okay guys, thank you very much, and have a nice day.